probably give, I guess we're 6 minutes after the hour. The attendee list seems to have slowed down its growth. So yeah, I guess I will kick it off by inviting anybody who hasn't been here at least twice. If you'd like to introduce yourself, come on camera. You don't have to if you're shy and don't want to, no pressure, but we'd love to get to know you a bit.
I think that applies to me. So I'm Chris Lamb. I'm here sort of representing the reproducible builds project, all about, you know, trying to prevent problems in software supply chains, through a distributed model of consensus about what if a given build produces the result in every situation. Then you can check that if you distribute that, then, so I'm not explaining this very well, but if you distribute that, you can see whether any particular tool chain has been compromised. And this project is sort of, was very interesting to me. And then I realized there was a demo a couple of weeks ago. And I also have a big background in the Debian project as well. So those things just overlined. So I just thought I'd just look and see what's going on here. So very nice to see you all here.
So my suspicion is, with your general bias towards reproducible builds, that you're probably fond of our artifact tree singularity principle, which is if you have a binary and it's the same bytes, you should have exactly the same artifact tree as everybody else who built it.
Yes, similar, yes. And it also somewhat overlaps with ideas of how we want to record build metadata ourselves. So a lot of things, I think that you folks have already maybe ironed out, or maybe they're at the same problem or something like that. Anyway, this is very early days.
Well,
but
there are some interesting ideas that are probably more perfect for the spec call that would be fantastic to discuss on that, because we have sort of thought a little bit about that, because it turns out, like, obviously you don't want to graft the build tools tree into the output tree. That's wrong, because the components of GCC are not in fact components of the thing you built. But you do want to know things about the build tool and the build tool's configuration, but non-ephemeral things. The one example I always give is, we probably don't want to capture -I, because the fact that you built it in your home directory and the fact that I built it in my home directory should be immaterial.
Yes. And we've been wrestling with similar things for a while, with not getting always the right answer first time. So yeah, we good. I'll have a think about that. That's great. Anyway, that's enough about me. So next.
I think you may be the only new person this week, unless I'm mistaken.
Yeah, I think Chris might be the only.
You're certainly very welcome.
Yep. And if we missed anybody or somebody else just joined, it looks like someone else might have just joined. We're just doing the intros right now. You're welcome to speak up, or if you're shy and don't want to, that's also totally fine. Ed, if you'd like to share your screen, I think the next topic is
that's right.
yours.
Oh, that's true. Also, it's useful sometimes to have the agenda up.
Yes, well, the next topic was the
right. So the build tool community outreach tracking spreadsheet. So one of the things that we actually have been doing is tracking sort of communities that we want to reach out to and be in contact with, and at least capturing who has contacts in the GitBOM community with those folks, and then sometimes with the consent of the parties in those communities, listing them as well, and maybe some notes about that. Just because as we try and roll this out, the goal is to sort of get to a point of ubiquity where this just happens as part of the normal process of people building their stuff. Instead of having to do something magical or special, it's a, did you build? Yes. Did you use llvm playing? Yes. There should be this little directory that you find where your binary came out that has everything you need to publish. So if folks know other communities we should reach out to, feel free to add them to the spreadsheet. There's a link from the meeting minutes. If you have folks or our folks, for example, I think we've got you listed here, Chris, for reproducible builds. You may or may not, depending on your current status, feel sufficient for that for Debian. I've known some project leads in the past who had sort of wandered away, but it kind of varies person to person. So just wanted to sort of raise that up to folks' attention again. It's an ongoing process. So I think that's all for that item.
So I will explicitly reach out to more JVM people this week. And I have been talking to the Sneak folks, and they do a lot of stuff around JVM. So I'm trying to find the appropriate person within Sneak to lure into our band of crazy.
That would be that would be fantastic. I did have some conversations with some of the OpenJDK folks and some of the Eclipse Foundation folks, and there was a general sense of supportiveness. But that whole space is so huge, the more people we get involved, the better.
Yeah. Well, I think there are also some really, really interesting corner cases.
ASM much?
So should we move on to check-ins from our 4 POCs? Before we dive in, did anybody from those 4 have any major updates or a POC, like a demo you wanted to show off today?
Yeah, I want to show update, a demo today. Yeah.
Okay. Anybody else? I want to make sure that we have a sense of how much time everybody is looking to get today.
If there's time, I would also like to show an end-to-end working with the clang and LLD linkup.
Awesome.
That's very exciting.
No demo for Rust. I'll post a video later, but I'd be happy to give a brief update.
And I also have some stuff to discuss POC wise that's beyond simply the Rust code. So if I could have 10 minutes to do that, I'll gladly take the end of the meeting. So if we don't talk about my stuff, no worries.
Okay. And I see Frederick on the call. Did you want to talk about the Go work at all? If you're talking, you're muted. Okay, I'll put Go at the very end. Then let's go llvm, then bomsh, and then saving 10 minutes or so for Rust at the end. Okay, Aditi, it's all yours.
I'll share my screen. Oh, I have any permissions to share?
I've stopped sharing, so that should not be an impediment.
Okay. No, I should do that. Okay, so you can see my screen.
Yes.
I'll just start off with very basic example to just show the. Okay. So here. This is with the compiler that we have already seen. You can see that the .bomb section has 20 characters, and what gets generated in the GitBOM is the GitBOM file that's human readable is the hash of all the dependencies of a.o. So now let's.
Right here, you can use the readf-x option.
Yes.
That will be more readable.
Redex is the hex, and you can see that this file is there in like 04. This hash is what contains all the dependencies of .o, the hash of the dependencies of a.c. That is, and then this hash is then embedded in a.o in the .bomb section. So this is with the compiler, and now you're linking to get the binary. So for that, new option --GitBOM has been added to the LLD linker. And now you can see that this is the hash in the .bomb section. And let's look at the contents of what is there in 2133 file. So only for a.o we have the information from the .bomb section. The other dependencies, mainly coming from the shared objects and other libraries that is being used for the link, are not built with the GitBOM enabled toolchain. So we don't have the BOM section in those dependencies. So nothing else is put out for those entries. And this is basically the end-to-end end-to-end implementation. So I just run this on openssl, and so I can show that reader-x crypto.piso.3. Then we can try to see what is there in the GitBOM for this. So this is all the dependencies. So basically, this is a complete end-to-end implementation that has been shown for BOM SSL. And you can see a lot of these GitBOM object, the GitBOM files are written in the places where the object files are also generated. So for example, yeah, all of these are here. So based on my exercise of doing this implementation, I just had some points to share that will be useful if it just gets, you know, spelled out in as part of the spec, even though some of them could be implicit, just so that we minimize the deviation, you know, in the implementation defined behavior part of the prototyping. So first was, I mean, there were some differences in how the different tools that I've seen used the naming, meaning whether you have a .bomb section or a .gitbom section, and you write the files under a .gitbom directory or a .bomb directory. I mean, this is trivial to fix, but it's better if there is something that's just called out explicitly, so we don't have very many differences. And also writing of the hash, initially I had actually written them out as 40 characters as hex. But I think my understanding as looking at the other implementation as well is that you write the GitBOM file human readable, and the one that you embed in the binary is 20 characters. And similarly, I think the naming of the file is probably pretty clear now. It's 2-character BAR name followed by 38 characters of the hash. This was already discussed, the difference in what hash we use. So currently SHA-1 is being used, but we're not associating the hash with any particular kind of hash. So whatever is there in the .bomb section, whatever hash is there, it's just that hash is just taken and being used. It's not, you're not distinguishing what type of hash that is. I think there are already discussions on that topic. The other one was what is the meaning of a dependency here? Currently, I'm relying on the dependencies that are listed out by the compiler and the linker. When we use, there is a specific option -md for the compiler and -- dependencies for the linker. So I'm just going by what is the semantics used in those options, which is whenever a file that is read during the part of compilation or link, those are counted as a dependency. But let's say you have a file that is conditionally included, and in my compilation, I do not use the macro that enables that inclusion of that file. Do you want to count it as a dependency, or that's not a dependency? So that comes to the next question of what kind of metadata do we want to collect in order to have these verifiable artifacts. And I think David already brought out the question of what about the compiler? So, so I think compiler is one. The other one I would add to that list is the compile options, because if I use a different option or even different optimization level, for example, then the binaries are going to be different, the hash is going to be different. So I think around the topic of what metadata to be collected, I think there's some discussion probably is required. And then lastly, during linking, I think it's clear for us that if we don't have a .bomb section, then we just leave it out. And objects built using different hashing schemes are currently, they are treated alike, but if there's any difference, I think we have to modify our implementations going forward. That's it from me.
No, I think those are all actually excellent points. I'm the deep discussion of some of those questions is probably best for the spec call, but I suspect, Chris, that you may have some insight on like which pieces of things we might want to capture and how from the information about the build tools, sort of the essential versus the ephemeral information.
Yes, we've been doing this in the reproducible builds build info format. I guess your specific question went to compiler and linker flags. We don't record those specifically because they're implied by the toolchain, and it's just assumed you're going to use all the default options. And so it's not that helpful from this point of view, but we certainly do record some ephemeral, well, some build metadata, but obviously like the architecture that was being used, what were the build dependencies and what exact versions were they, things like that. I can sync up with you maybe on the spec call to go over I can bring some build info file.
That would be super useful to look at, yes.
Yeah, that'd be.
Because we're all sort of feeling our way, and like I have, you know, what I would refer to as some strongly held opinion, some strong opinions lightly held, if that makes sense. So it's easy to point out to me that I'm wrong about some of these aspects of it. But I mean, I know one of the things that we've talked about on this that might be something you might have opinions on is there's going to be certain kinds of information that are actually of metadata that are sort of local to the build tool, right? So llvm has a notion of what llvm's essential configuration is, for example, right? And then there's certain kinds of information that we should be able to do in a relatively generic way. Like if you're a build tool, we would kind of like to know some human readable notion of who you are that you're going to be consistent about as the build tool and how you express. We'd probably like to know some appropriate hash of the build tool. And we'd probably like to know the GitBOM identifier of the build tool, so we can start capture, if available, so we can start capturing like the full forensics of the build tool itself.
Gotcha.
Oh, your hand is up, David.
Yeah, you just after I raised my hand, you made my point, which is have a .bomb section or .gitBOM section in their metadata, then we only need capture that, because that should be a pointer to all the other information that we need.
Mm-hmm. Yeah, it's going to be interesting. And I think like a certain amount of it is going to be local to the build tools. Like Go is not going to have the same opinion about what is essential configuration information that llvm clang does. So
yeah, I mean that starts getting really detailed, and probably there are good arguments for a variety of different things. But if we look at the build tools as things that also have GitBOM information embedded in them, then capturing that information is an easy first pass as part of the overall thing that produced the .o. The .bomb section in the linker then will point us to the thing that linked the things into the SO or into the executable or whatever. And, you know, as we pull on that, I'm sure we'll find other things, but you know, this is, I think, a bootstrap issue rather than a long-term issue, which is once GitBOM becomes part and parcel of the way that we construct software, then it should be everywhere, and we should just be able to say to a tool or query the tool saying, and what's your GitBOM? And everything else flows from there.
So I still think there's a little bit of configuration information that's not intrinsic to the tool itself. So like the very, very classic one would be, while I think -I for specifying include directories is almost certainly ephemeral data, things like what preprocessor flags did you set to what values at the command line for C, that's probably consequential metadata about the build.
Yeah, and I think, you know, working with the reproducible build folks will help. You know, we don't have to reinvent that. And if we do stuff the way that they do it, then, you know, look, if there's some gray area and they make a determination as to how to resolve the particular gray area, I think it's better that we simply adopt what they do rather than try to roll our own. Because, you know, at least in my experience, almost every case of gray area, if you have two, it's exponentially worse than if you have one.
I'm very inclined in that direction. Plus, I imagine the reproducible build folks have a lot of experience around which information is impactful on the outcome, which versus which isn't, right? So, you know, that, anyway. Vicky.
Turn that. I see Vicky's hand up, but I want to just pivot.
Go ahead, David.
Since Chris is here with us, if we have questions like that, maybe, is this a good time to ask Chris or have a follow-up?
Well, that's kind of related to what I was going to get into, which is I'm not sure how many people on this call are actually familiar with reproducible builds as a project, because it has been around for several years and it's pretty well established right now. And I think it might be worthwhile to schedule some time in a future call to have them come give a quick overview of all things, reproducible builds, to give everybody kind of a baseline so they can start figuring out where the collaboration points might be, because I do think that they've got a lot to contribute to this community.
So we're looking for a reproducible demo.
Reproducible demo, yes. I think we call it a video.
We've heard all of the jokes, it's fine. Yes, I mean, I've got a little 15-minute, 20-minute package, sort of precisely this kind of thing to slot into a meeting at some future. I can do that on a week's notice, say. And I think that'd be very helpful, because we will start to see which parts of GitBOM and reproducible overlap. I mean, if only in the compiler options kind of thing. Because a lot of, I mean, we completely agree, as in the reproducible builds agrees, which I think is your sentiment, Ed, about having the minimal amount of build recur, but like some of it's ephemeral, some of it's not. But we're pushing in, I can already see we might be pushing in slightly different, sorry, not pushing in different directions, but heading towards different goals, because we want as little as possible to affect the build by design. And so, you know, if you could have different include parts, but the build becomes the same at the end, that's actually more ideal for us. But we're slightly getting into the weeds, and maybe this
for us as well, right? But that's where the operational experience helps, because you have a good sense of like things that should not cause a build to change, right? And we would not want those to cause a different outcome on our side either.
Getcha. Yes. And then there's a difference between things that we don't want to affect a change in the build, and things that actually do, and as are trying to, you know, in an ideal world they would, but as they actually do in real life, then, and if you want GitBOM to actually work, then you have to now record them, because, you know, life. And then so yeah, there may be a sort of, I don't want to say a split there, but a difference of.
And if the reproducible build community has a set of I don't know, guidance or learnings or best practices across different languages, not just the 4 or 3 that we have working with us right now, but all of them or more of them, that would be really useful resource to the GitBOM community as more folks or more languages are joining this work. Just say, hey, if you're looking for guidance, it's right there.
Yes, and we have some of that in some communities. A lot of the reproducible builds folks are more in like the sort of the packages, distributing Linux distributions sort of space, not necessarily like in the llvm playing around with elf files kind of layer. I mean, not really this kind of. So.
We're actually kind of fine on all the layers. The reason we have LLVM stuff is we want this to simply happen as a thing that nobody pays attention to. It's just there.
Yeah,
right.
But Chris, do you mean at the Debian or RPM layer?
Yeah, I think we are well represented in that level.
Okay.
In that layer, not necessarily in the particular compiler sort of GCC level, but yeah.
I think having GitBOM integration in those build layers as well is also important. I had a conversation, I guess it's been a few months now, with the Docker folks on how we might store this and propagate the same kind of metadata, a GitBOM hash, in a Docker image manifest. Their answer was, yeah, piece of cake. We don't even need the IANA code to be approved, but it'd be great if it is. And I'm going to try and get them to come join one of our calls soon, but I have not had a chance yet to chat with, or say, RPM folks to how does this fit into an RPM pipeline?
Right. And I've had some discussions with some of the Enclave folks about like, okay, how would we actually represent a running executable instead of just the executable at rest? Because in a running executable, you'd like the tree to also capture the .so files that your dynamic linker has linked in, for example, in C, or the class files the class loader is pulled in Java. So how do you actually capture that meaningfully and continue to have a tree going forward?
Can I get a comment in here? I'm sorry, this is Elliot. I know I'm not raising my hand, but I have a little bit of a meta concern about the direction of the conversation, which is I don't think the be all and end all should be about the GitBOM, just the GitBOM. GitBOM is an important part of a breakfast, but it's not the breakfast. And what I mean by that is that people need certain other meta information that's tied to it. And already we see, for instance, with Alpine, that the APK is going to generate cyclone.dx files. It would be, I think, better to devote your time to A, making sure we can generate these darn things in the first place, B, understanding how we're going to consume them, and then see how they slot into the existing formats. The current cyclone.dx and SPDX formats, in my opinion, could stand a good stare in terms of what that hash that they have means, right? And at what object level. Because you might even be able to shrink some of these SBOMs to something a little bit more manageable and useful if you can simply point to a GitBOM to pile them out. Because right now, there's an expression that I think is popular in the industry and especially in standards, and I realized we're on the wrong day for that. But it's turtles all the way down for some of these formats, and you guys might actually help keep things from going turtles all the way down if you can if you can have the right pointer in these formats, and that way you don't have to define anything new except for maybe how you're defining the hash function, as we discussed was it 2 meetings ago, I think. So I apologize for taking the floor for so long.
No, good feedback, absolutely.
And the idea of how GitBOM and other SBOMs like SPDX and cyclone.dx, how they are connected, totally on point. I'm not sure where that's probably better to land in the spec discussion. I'm hoping to get more SPDX folks to join over time, but not moving this work into the SBOM space. And And I'm happy to join if there are other SBOM, if there are SBOM discussions that would benefit from understanding GitBOM and our hash. Let us know where to go. But I do want to move on and just keep track of our time. Elliot, I see your hand pop back up, but I'm watching our time. You have a quick comment?
Yeah, I apologize for taking the floor again. My point is merely a matter of work optimization and slotting things in architecturally, right? There's a lot of work to do, and you know, everybody's, I think, a little frantic in this space right now. Just if you guys, and I should say we, can produce the best quality GitBOMs and provide guidance on how to read them in, that's good enough. That gets us a long way. If we can interact with the compiler people to get them to generate the tools generation, wow, we are so far ahead of the game if we can cover that ground.
Yeah. With that, I would love to give the floor to Young Kuei if you have some demo to share for bomsh.
We miss Frederick.
Sure.
Frederick had had his hand up for a while now, I think.
Oh,
Yeah.
Thank you. I didn't see that.
No problem. But adding to what Elliot was saying in the previous one, I tend to try to think of this as a cryptographic receipt. So one of the things that I think we need to be careful with is a lot of people will make the assumption that we're trying to compete with CycloneDX or SPDX or similar. And what the way that I've been trying to explain to people is it's a cryptographic receipt that allows you to that you can embed into other systems, or embed into an SBOM, or have a receipt of an SBOM itself, or so on. So whatever you can create that receipt of is basically what the GitBOM is. And when you start thinking of it as a cryptographic receipt as opposed to a bill of materials, and what can you do when you have receipts that can be nested in other receipts, then it helps. It seems to help people understand more accurately the type of things that we're pushing for. So just as a possible analogy that people can use.
Cool. So Young Kuei, you may want to go a little bit more than the usual explanation, because I think this is going to be very interesting to Chris, but I don't think he's seen bomsh before.
Sure. Let me also show the bomsh. So yeah, the bomsh tool, we have demoed the bomsh framework. Actually, we can run the software build with our bomb trees tool that will automatically record all the shell command that's running during the software build. And then we analyze the shell command, figure out what's the input and what's the output. You can see we capture all the shell command. Then we generate this kind of input file, output files. Then we generate the GitBOM database based on that. We don't need to embed any .bomb section into the generated binary file. That means we can work well with the reproducible build, because for any debian package that's reproducible, we can just reproduce the build and generate the GitBOM tree. That means that we
really quickly, and I'm so sorry, if you can go back to that previous slide, you keep glossing over truly incredible things your tool does, and I can't deal with it anymore. So if you go back to slide, oh yeah, the slide. I know slide 12 actually. No. Yeah. I don't know if folks noticed, but in this one, somebody had a piece of assembly that was importing a VM Linux bin into a .o file. We just lost your slide there. Okay.
Sorry.
Yeah.
Can you see?
So yeah, I see now. But basically, it's literally catching the capture of something that's just being pulled wholesale binary into a .o file, which that makes me happy every time I see it.
Yeah. So yeah, basically for the Linux kernel build, right? You can see we it actually embeds this VM Linux into the pg.o. And we can actually go deeper into this and create the input-output file relationship between this actually BZ image file and this VM Linux bin.file. That way we can track down from the compressed Linux kernel to the real source code. That's something we can do with bomsh. Yeah. Yeah, it's just a Python script that we write. We can do whatever we want for the for the field, for the file software build. Yeah, that's why.
Chris, does that start giving you a flavor kind of what we're doing in the tool?
Yes, it does. I suppose my only technical question is, how is it intercepting the shell commands? Is this
it's using the S-trees to run your build. Okay. Yeah, then capture all the process creation, then you get the shell command. Yes, and then you can also access, calculate the git hash of all the files that you can access during your software build. So that's why it's powerful of doing that.
Getcha. I mean, it was a technical question, but that immediately puts it in it's a very general purpose tool, in other words.
Yeah. So basically, the bomsh framework is that we do the software build with our bomb trees tool and invoke the Python script to generate the GitBOM database. And then we have also the create CVE script to scan your Git repo and create a CVE database. And then together, give me a binary file like this openssl binary or the VM Linux BZ image. Then give me the git hash of that. I can search in the GitBOM database and CV database, generate the whole CV result for your binary. So for all the reproducible build Debian packaging, we should be able to do that. I have shown with the kernel and Linux openssl. So it will just like this. It will tell you this summary. Then we have the whole GitBOM tree to show you what root code, which source file called this CVE. So basically that's our previous demo has done with this kind of database. We have for the log4j, for example, we have done that for this vulnerability. We can easily figure out what's root cause for that. So today I want to share some progress on this create CVE script. So basically, we are having this kind of like a proposal or like that. It's some practice. So basically, we take openssl as the example. So we go to the Git repo and find out the CVE related commits. So we flag some of those commit as CV add commit and some as CV fix commit. I use 7 high severity CVE in the past years for the openssl. Then for each commit, we create a YAML file. You can see for this CVE, we create YAML file added. This introduce this CVE. And it's a feature commit. So we only focus on this specific.c file, introduce this CVE. And then later we have 2 commits that on different branches actually fix this CVE. We also, if you don't list the source file, by default it's all the source file in your change site. So we'll have all these 3. Right, we just read them, and for each CV you have the added list and the fixed list. Then we run some git commands to figure out which one are the blobs for those CV.c files, which belong to the no CV list. That means before the CV is introduced, and also the CV list that's from this CV add commit to the CV fix commit. And then also the fixed CV list, that's for each branch from the CV fix commit to the height of that branch. Yeah, do that for this. So basically the algorithm is here. So basically that's how it works. So it should also cover more complex cases. But I know there's some complex cases, for example, for a new Linux distro, they have some patching after pull from this Git repo, then that we need also some work to cover that, I think. But basically, if it's just built from a fixed Git repo, we should be to just using this approach to create a list for the other .c field affecting this CVE for the other blobs. For example, openssl, we already have some examples. We classify them for those blobs. Then we create a CV database. Later, right, using our bomsh tool, right, then we will be able to do the search for all the debian packages. For example, the already released openssl debian packages, we should be able to just using the two database we created to get the whole list of CVE, vulnerable, fixed, that kind of thing. Here, I just show this script, the bomsh create script. I just ran it with 26 seconds for totally the 7 CVE, high severity CVE I have generated. So you can see that's the result I generated. So each of those, for example, this one, I think, let's see, this one, you can see for each CVE, we generate for this .c file, some blob, at least blobs. This is actually vulnerable to this CVE. And this is the blobs that have fixed this CVE. This is the blob that before we introduce this CVE. That's like this kind of result. So what I use is just, I create this kind of information, YAML file for each commit. So we can also do the git tag to use annotated tags to attach this this info right into just the let's see, I already did that in some, you can see here git tag. If you do this, you can see I already tag some of those here. Then we can also, this will go together with your Git repo. So everybody pull, it will automatically pull this information. Otherwise, we keep, actually, I already created a new Git repo, you can see. For some heart bleeding CVE and some recent high severity CVEs for openssl. Just each one, we create such a YAML file. Just a CVE info dot commit ID dot YAML. This will be usually the 7 first digit. And if not unique, we'll add more like that. So if we have this kind of information for all the Git repo, for example, openssl, then we should have the whole CVE database we can create using the bomsh, our tool, to create this kind of database. Then it will be used for all the debian packages, for all the reproducible build debian packages. We should be able to create the whole GitBOM tree and also search the CVE list. So that's just some ongoing work. I know still some other corner cases we may need to cover, but basically that's the current, I think, the general algorithm that we will use. Any comments, question? Yeah.
So that's actually super interesting. Sort of the algorithm, how you're sort of putting together a good enough after the fact CV database, which we can then match against the GitBOM trees to figure out who's vulnerable. You had talked last time about some stuff with this around reproducible builds, or being able to produce GitBOM trees for existing Debian builds,
yes,
which could then be used for this sort of purpose. I realized we did talk about it in the past. It might be worth talking about, since we have Chris here, a little bit again. Unless we are we're a little bit tight on time. How do folks feel about that?
Yeah, so I just use the dev rebuild Python script to do that, I think, for the some work for that, I think.
David and Nell, do you both mind if we bump your topic to next time?
I'm okay with it. David, what about you?
I was muted. I was saying I'm good with that. So yeah, but this is like enthralling. I just love this.
Yeah. And then a question for Young Kwai. If I understood your demo correctly, what you've done is used deb rebuild to rebuild many different versions of openssl to generate the GitBOMs for each of those. You can then verify that those are the actual released versions along different branches or different version numbers. And then with the built GitBOM, you can cross-reference to figure out which ones are vulnerable. Is that what you did?
Right. Yeah, that's right. So I just, you can see for any deb rebuild script, right? I just add preface act with the bomb trees. So this is just using S trees run your build, and then we'll be able to generate the exact same identical byte to byte, bit for bit identical binary files. And during the soft build, we'll generate all the, all the GitBOM artifact tree to document. Yeah. So basically, that's how I did that. It's just using a script. Yeah.
One small question actually is, when you were generating the list of hashes that were vulnerable to a particular CVE, what sort of order of magnitude of actual commits were you finding in those real world cases?
Yeah, so here, right, this kind of thing.
Yes.
So we can pick one as example. I think this one, maybe I have some, I think. You can see this kind of thing. So this one fix, right? So you can see this is just a very simple one, just one single line change. That's very easy. And some of those are multiple of those files. So I use the git log -s to pick a few lines in this change site. Then I should find out which commit introduce that line, right? So usually take some time. I spend one day and then I identify 7 CVEs, high severity CVEs for openssl. That's all of those I have. You can see. Yeah, that's the commit. But I think if it's the openssl developer, they should be much easier to identify the one to introduce the CVE. But for the CVE fix commit, it's very simple. Usually in the git log message, the last line will usually, I think the last line will usually be the CVE ID. Yeah, they do this. So finding the CVE fix commit is easier, but it's challenging a little bit to find the CVE add fix. And sometimes it's day 0, CVE, it just track all the way to that file when it's created. Yeah.
Is that database, I mean, the commits that will encode, that'll be quite big in some cases, right? If the vulnerability has been around for a while. I'm just wondering how big these databases will be. I mean,
yeah, I think eventually it should be the developer, the Git repo software, the developer themselves to do this work. This is just like a proposal, best practice for the new CVEs that you better follow. Then we should be able to capture this kind of CVE information for our GitBOM work, right? Otherwise,
there's also an interesting thought about how you represent them, because right now we're sort of mapping CVEs to blobs, which is perfectly fine on a small scale. I suspect when you get to a larger scale, the inverse of that is going to be more interesting, mapping blobs to CVEs, because then I can ask a very small question of a very large database instead of asking a very broadly ranged question of a very large database. So like a broadly ranged question in a small database is perfectly reasonable, but the inverse could be something as simple as a simple URL pull.
So what we're looking at here is how GitBOM provides the foundational tool to build this. What might something look like over time as these two data sets are both built out, and then something is able to put the combination of them together without a combinatorial time to do that calculation. And there are currently commercial ventures that are somewhat similar, at least on the CVE polling side. We can hash a file or hash a package and say, are there any known CVEs in this binary or in this package? I'm not aware of any open source to do that, though there is some work. I think Google has just proposed or started to do as a public endpoint that can be queried with that data for some open source projects. The company WhiteSource operates a commercial service that does this, again, for some content. And so over time, I think we're going to see more of that, and GitBOM adds to it. I think this is the idea of being able to rebuild this for past releases. I think that's a really key takeaway from what Youngkwei just demoed, that I had not been considering either a goal or estimating how much time and complexity that would take. But I think that might be really good to bring up in the OpenSSF over time of like, is it worth recalculating this intersection for some small set of critical software components over time?
Yeah. I mean, it's really interesting because in the POC meetings are both the best and the worst for this, because we all get very excited and we've all done, GitBOM itself is intended to just get sort of at the particular core of the problem. How do we construct artifact trees? But it is irresistible once you start moving that direction to start doing some of the cool stuff like what Youngkwei's done here, where you sort of reach a little bit past that to how you could apply it to things. Because it turns out when you actually can get the artifact tree, everything is easier, right? If you've got the artifact tree, you've got it indexed the way the source code files are indexed, a huge amount of stuff becomes much easier to do. And we just can't, being engineers, we can't quite help ourselves. So.
Yeah. I think about openssl, that's a very critical project, right? We should be to find somebody, volunteer, either volunteer or funding to just, for the CV information too.
Well, let me sort of ask this question to Chris, because you were Debian project lead. And I know Debian has its own build machinery, right? So like, we would need to, of course, get a sense of like how expensive it is to run something like a bomb trace, how much the incremental cost is to run bomb trace across these things, to construct the GitBOMs for already constructed, for already released Debian packages. But I presume that there would be resources to at least experiment with this on some things and see what they might be able to reveal.
I think for it to essentially run strace on every build from now on would not be will not be possible. But I know that,
Okay, I think I'm down.
But every so often you get academics, say research projects, rebuilding the entire previous Debian release with all sorts of bizarre configurations of virtual machines. So to do it once on like a released archive, say the stable release, where this is where this probably really matters, is quite feasible. I mean, it doesn't actually take weeks to rebuild anymore the entire thing on fairly readily available hardware. So this to rebuild the archive and get bomb traces should be possible. I mean, apart from where strace will break because it's not like 100% reliable for some builds. But yeah, that's certainly promising.
Interesting. Okay. Cool.
So just on that topic, random brain synapse firing, it might be interesting to see if Brian Cantrill might have some interest in this stuff, because some of the stuff they're doing over at Oxide, I think, intersects with this. And given Brian's, previous history with dtrace, he might be able to lend some thoughts. Let me pester him and see whether he'd be interested in attending one of the meetings.
And if you need assistance in pestering him, just let me know. I know him too.
Okay.
Awesome.
Yeah, that sounds good. Are we following each other on Twitter?
If not, we should be. So I'll
So,
go with
Jeremy, I see your hand, but we are at time. I want to be respectful of that and thank everyone for the wonderful demos and the really good discussion. If your questions can be captured, stick them in chat. We'll bring it up next time. And see you all in a week for spec work, and in 2 weeks again for more technical talk and demos. Thanks, everybody. Happy Tuesday.
Thank you.
Thanks.